Assalamu alaikum. My name is Muhammad Khan 221714. So our final project of EDC was Edge Bridge. So basically, the Edge Bridge is an electronic device which is used to change the polarity of voltage which is applied. Mm. The basic purpose of this Edge Bridge was to rotate the DC clockwise and anti-clockwise. As you can see, uh, the components arrangement shows a view like H, so that's why it is called as edge bridge. Edge bridge is used to supply power to a two-terminal device. By proper arrangement of the switches, the polarity of the power to the device can be changed. Changing the polarity of the power supply to DC motor is used to change direction of rotation. Apart from changing the direction, the edge bridge can provide additional modes like brake and free run until the frictional stops. The edge bridge arrangement is generally used to reverse the polarity or changing the polarity of the motor, due to which we can achieve what we want. Like we want to control the polarity so that we can move the DC motor, which is here in center in this edge bridge, to rotate in clock and anti-clockwise direction. For example, if the voltage is given and we want to rotate it in anti-clockwise or clockwise direction, for the clockwise direction we will give the input at V, so the Q1 will be on as well as the Q4 will be on. So this will be the basic path of the voltage. The second diagram shows the arrangement for the voltage applied, so that the DC power motor will be moved anti-clockwise direction. Here are some of the components which are used. For example, optocoupler. The basic functionality of the optocoupler is the isolation of the different parts, uh, due to which it will give us the surety and safety. The resistor were 10k, 1k and 430 ohm. The capacitor for the start storing JFETs. For here I use JFET junction field effect transistors, 4 of them. Diodes were also full. DC motor, one motor connecting wire and push button. The push button were one of them is enable, as you can see in here in Proteus. The one here is enable, the top one is forward, the middle one is reverse, and the bottom one is for enable. So as you can see, the PCB here is two resistors connected to the optocouplers. The resistor is 430 ohm, and there is optocoupler PC817. Again, then there is two resistors of 10k and 1k ohm. Continuing with the JFET, two JFETs, and there are two flywheel diodes in front of it, to each one to each one, and in between, in the center, there is a DC motor. So this is the proper Proteus which we use for the purpose of edge bridge, using optocouplers and many more functionality components. This is the PCB layout which we were used for the simulation of test bench, which were also one of our assignment. This is the simulation of test bench, as you can see. So the final conclusion is of the Basic presentation of this task is the use of edge bridge in DC motor. Control is simply an easy way to control the direction and speed of a DC motor. The real change lies in the choosing those integrated circuits as power supply that are related to handle the voltage and current the motor would draw. So this was just a overview presentation. So let's move to the detailed one presentation, which were actually our presentation on our project design of an edge bridge circuit. The first one is our objective. So to design an edge bridge circuit using BJTs to control the direction of a motor, optical isolation and flyback diodes. ठीक, right? BJTs. So here we use FETs, JFETs, field junction effect transistors. So the conditions here is the motor runs at 9 volt and at maximum draw of 2 ampere current. The another condition is the motor is to be applied to continuously for 15 minutes. So these are some of the conditions, like 9 volt, 2 ampere and for 15 minutes operation. Here there are the detailed equipment list. Optocouplers ICPC 817, as I already mentioned, quantity is 4. Resistors of 470 ohm, quantity is also 4. Resistor of 1k and resistor of 10k, the quantity is 4, right? Diodes. So the diode I used here is UF4007. The quantity here is the diodes is of 4. We write it 1. The diodes is basically 4. We are using flyback diodes, which is basically with in front of JFET. Another is capacitor. We use 4 quantity 4. Here also mistake. We are not using 1. We are using 4 of 100 ohm, 100 nano. Sorry, excuse me. MOSFET. We are using 4 MOSFET. Another one, the two are IRF 9540 2, and another MOSFET is IRF 540 of 2 quantity. Simply one DC motor. The push button are 3, which is forward, reverse and enable. Breadboard to check our circuit, and the last one is battery of 9 volt. Excuse me, sorry. The battery of 9 volt is also of 1 quantity. To a 210 device, but a proper arrangement of the switch, the polarity of the power of the device can be changed. So what is basically edge bridge? Edge bridge is an electronic device which is used to change the polarity of the applied voltage or the applied load. These circuits are often used in robotics, as we know, related to mechatronics and other applications to allow DC motor to run forward and backward, or we can say clockwise direction or in anti-clockwise direction. As you can see, the arrangement of the all components are in such a way that it shows us overview like H. So that's why it is called an H bridge. Protection diodes and PWM modes. A side effect of how a motor works is that the motor will also generate electrical energy. Yeah, as we also all know, when you disable the transistor to stop running the motor, this energy needs to be released in some way. Yeah, this energy also produce back EMF, which needs to be, we called, to be removed or to be released from the whole circuit. If we didn't remove this energy, it will create damage or it will damage our circuit. So if you add diodes in reverse direction for the transistor, you give a path for the current to take to the release this energy. Without them, you risk that the voltage rises and damage your transistors. See? So the basic purpose we use diodes are basically we call it flyback diodes, so that the extra energy which is generated to be released, right? So this is a project detail. This is a Proteus. As I mentioned, three push buttons: enable, forward, and mm, reverse. The previous Proteus simulation was blurred, so this is a proper simulation, or you can see it in the Proteus here. I can show you. This one is input peak, right? With input, this is push button 1, this is push button 2, and this one is enable. This is resistor 470 ohm. This is also resistor 470 ohm. Each resistor of 470 ohm is connected with the optocoupler for the isolation purpose. Next, the optocoupler is connected with the node 4 to the 1k ohm resistor. Same the optocoupler 3 of PC. The optocoupler is basically PC817. So this optocoupler is connected to terminal 3 with the resistor 5 of 1k ohm. This resistor is connected with the 10k ohm. Same, the below resistor is connected with the 10k ohm. These both have then the connection nodely with transistor. We can say JFET. We are using here JFET. So it has connection with them, right? So this JFET has in front has a diode UFO4007, which is used for the purpose to release the back EMF as we mentioned previously. So these are the flyback diodes, flywheel diodes. In here the center, this is the motor. uh, we are here using basically the motor. Let I show you. This is the motor, right? With motor there is capacity to store the charge for this charging purpose. Same on the right side, the same components are arranged, so it is giving a proper edge bridge simulation to us. So this is off mode, and this simulation is in on mode. As you can see, we give here input of 5 volt, but in practically we are giving 9 volt. So this is our basic simulation. This is PCB layout of this simple one, but we are using this one PCB layout. We use this PCB layout to execute our project. Applications of edge bridge circuit. In robotics technology, edge bridge circuits are used, as we are know, because in edge bridge there are the for the purpose to move the robot, there must be an edge bridge to control its direction. Edge bridge circuit is also used as inverter circuit. Yeah, as we know, in modern battery charger for electrical vehicles, edge bridge circuits are used. Advantages of edge bridge circuit: very high efficiency, okay, very low loss. This circuit can be replaced in smart places. Yeah, this is one of the main. Conclusion: the use of edge bridge in DC motor control is simply an easy way to control the direction and speed of a DC motor. The real challenge lies in the choosing those integrated circuit and power supply data related to handle the voltage and current the motor will draw, as I mentioned already previously. This is our test bench simulation. This whole circuit, IO8, IO9, these are some inputs terminals, but this basic is Arduino of number 328. This is the whole Arduino we were using, and these three are our push button, enable, forward, and reverse, which are connected to our circuit. So this is our basic simulation. Our main test bench simulation is this one, mine, which is of mine one, but due to blurriness, I need to show this is too much blur now, which is not visible properly. So for that purpose I am showing you this one to give you a proper way that how it looks. So now let's move to the presentation video. So I show you how that how I simulated and executed our edge bridge project. So let's go and take a simple and